Recursive algorithm for binary search. Binary search of a, I, L, x. Name of algorithm is binary search. A is the linear array. I is the lower bound. Lower bound means index of first element in the array. L is the upper bound. Index of last element in the array. And here x is the element to search. Given an array A of I to L, array name A of I to L, of elements in non-decreasing order. Elements are arranged in sequential order, arranged in ascending order. Array is sorted. The search is performed in a sorted array. 1 less than or equal to I less than or equal to L. The algorithm determine whether x is present in the array or not. If x is present, then return I. Index of x. Index of x is I. If element is not present, then return 0. There are mainly two blocks in this algorithm: if block and else block. If block execute if the problem is small case. Else block execute if problem is large. Example 1. Here there are 15 elements in the array. Elements are arranged in ascending order: 5, 10, 20, 30, 40, etc. to 95. Elements are arranged in ascending order. Array name is A. Its lower bound is 1. I is equal to 1. And its upper bound is 15. Value of L is equal to 15. From these 15 elements, we have to find whether x is present in the array or not. If x is present, then return the index of x. Index of x is I. If x is not present, then return 0. A tree structure is used to explain this algorithm. So we create a root node. Root node contains 4 parameters, 4 values. Listen to the algorithm. By the search of a, I, L, x, there are 4 parameters. Those parameters are represented in the root node. A is the name of algorithm. A is the name of array. I is the lower bound. Value of I is equal to 1. L is upper bound. Value of L is equal to 15. X element to search. Here we search for an element 85. Those are represented in the tree structure in the root node. Now we are in the beginning of algorithm. If L is equal to I, that means problem is small. Now L not equal to I, 15 not equal to 1. So we go to the second part, second block, second else block. Reduce P into smaller sub problems. First find mid value. Mid is equal to I plus L by 2. 15 plus 1 by 2. 16 by 2 is equal to 8. Value of mid is equal to 8. Okay, mid is equal to 8. Then next statement is if x equal to a of mid. X equal to a of mid means x is which x is in the middle of the array. X not equal to a of mid. 85 not equal to a of 8, 70. 85 not equal to 70. Condition false. So go to else. If x less than a of mid, 85 less than a of mid, if 85 is less than a of 8, 70, condition false. 85 is greater than 70. So go to else. Here else is return binary search of a comma mid plus 1 comma l comma x. Okay, listen. If second recursive call is executed, then we go to right subtree of the row node. If the first recursive call is executed, if condition true, then execute first recursive call, then go to the left subtree. If condition false, then execute the second recursive call. If second recursive call is executed, we go to the right subtree and pass. Here condition false, so we execute second recursive call and pass parameters a comma mid plus 1 comma l comma x. Okay, we pass a 9, 15 and 85. A 9, 15 and 85 to the right subtree. A 9, 15, 85. That is, there are four parameters a 9, 15, 85, and we are in the middle of first recursive call or in the middle of second function. Okay, here I is equal to 9 and L is equal to 15. Problem is not small, so we go to the second block. Go to the else block. Reduce P into smaller sub problems. Mid is equal to I plus L by 2, 9 plus 15 by 2. So 24 by 2 is equal to 12. Mid is equal to 12. Next, we have to check x is in the right side of a of mid or in the left side of a of mid. That is, we know that x equal to 85, a of mid is equal to, a of 12 is equal to 90. Okay, so we can say x is in the left side of a of mid, left side of 90. Okay, so here condition, if x equal to a of mid, then return true, return mid. Else x not equal to mid, so else part, if x less than a of mid, condition true, 85 is less than a of mid, less than a of 12, less than 90, condition true. So execute the first recursive call. Execute the first recursive call, and in the tree structure we go through left subtree. First recursive call is binary search of a comma I comma mid minus 1 comma x. So pass a I 9, mid minus 1 11 and 85. Okay, a array name A, I 9, min minus 1 11 and 85 to the next recursive call as parameters. Okay, in the tree structure we go through left subtree. Now we are in the left subtree with the parameters A, 9, 11 and 85. Or we can say we are in the beginning of third function or in the beginning of second recursive call with parameters A, I is equal to 9, L is equal to 11, X equal to 85 in the beginning of a function, beginning of a recursive call. Here L not equal to I, 9 not equal to 11. So go to the next block, else block. Reduce P into smaller sub problem. Mid is equal to I plus L by 2. Mid is equal to 9 plus 11 by 2. 20 by 2. Mid is equal to 10. Next we have to check three things. X equal to A of mid. Otherwise if X less than A of mid or if X greater than A of mid. Okay, so next first statement is if X equal to A of mid, 85 is equal to A of 10. 85 not equal to 80. So go to else part. If X less than A of mid, 85 less than 80, condition false. So next execute second recursive code, last recursive code. Return bind search of A comma mid plus 1 comma L comma X. In the tree structure we go to right side, right subtree. We go through right subtree. Parameters are A mid plus 1 11, L is also 11 and X 85. Okay, parameters are A 11, 11, 85. Okay, now we are in the right child with the parameters A 11, 11 and 85. Or we can say we are in the beginning of a new function, new program with the parameters A 11, 11, 85. So first here check if L is equal to I. Here condition true. L equal to I. 11 equal to 11. Condition true. That means a small problem. Lower bound is 11, upper bound is 11. That means there is only one element to check. L equal to I. 11 is equal to 11. So in the inner of if there is another condition. If X equal to A of I, 85 is equal to A of I, A of 11. 85 is equal to 85. Condition true. So return I, return 11. 11 is the position of element in the array. Search is successful and return the position of element. Position of element is I and it is 11. Binary search is completed. Another example. A 1, 15, comma 20. Same array name, same lower bound, same upper bound, but there is a change in x. Here x equal to 20. We search an item 20. 20 is present in the array or not. So we create a root node, and we are in the beginning of main function AILX by the search of a comma I comma L comma x. First we check if L is equal to I, L not equal to I, 1 not equal to 15. So we go to the last block, else block. Reduce P into smaller sub problem. Mid is equal to I plus L by 2. Mid is equal to 16 by 2 is equal to 8. Next, if x equal to a of mid, 20 equal to a of 8, 20 not equal to 70, condition false. So go to else. If x less than a of mid, 20 less than a of 8, 70, 20 less than 70, condition true. So execute first recursive code, return by the search of a comma I comma mid minus 1 comma x. Execute first recursive code. So in the tree data structure we go to left side, go through left subtree. Parameters are a I is 1, mid minus 1 is 7, x is 20. Go to left child, left subtree, and parameters are a 1, 7, 20. Now we are in the beginning of an algorithm, beginning of a function, beginning of a recursive code, recursive algorithm with parameters a, 1, 7 and 20. That is also represented in the left subtree. If L is equal to I, L not equal to I, 1 not equal to 7, so we go to the else block. Reduce P into smaller subproblem. Mid is equal to I plus L by 2, 1 plus 7 by 2, 8 by 2 is equal to 4. Mid is equal to 4. Next we execute this statement. If x equal to a of mid, 20 is equal to a of 4, a of mid, that is a of 4, 20 not equal to 30, condition false. So go to else part. If x less than a of mid, 20 less than a of mid, a of 4, 20 less than a of 30, 20 less than a of mid, condition true. That is x is in the left side of a of mid, x is in the left side of a of mid, condition true. So here we execute the first recursive code, and in the tree data structure we go to the left subtree. Here parameters are a, I, mid minus 1 comma x. A, I is 1, mid minus 1 is 3, x is 20. And go to the left subtree. Parameters are a, 1, 3 and 20. Now we are in the beginning of a recursive algorithm, beginning of a recursive function with the parameters a, I is equal to 1, L is equal to 3 and X equal to 20. In the beginning we first check if L is equal to I, L not equal to I, 1 not equal to 3. So go to the else block. Reduce P into smaller sub problem. Find mid value. Mid is equal to I plus L by 2. 1 plus 3 by 2. 4 by 2 is equal to 2. Mid is equal to 2. Next we execute if X equal to A of mid. 20 is equal to A of 2. 20 is equal to 10. Condition false. So we go to the else part. Else part is if X less than A of mid. That means our item is right side or in the left side. We have to check item is in the right side or left side. First we check if X less than A of mid. 20 less than A of 2. 20 is greater than 10. So condition false. 20 not less than A of mid. 20 not less than 10. So else, go to else part. Second recursive code. Return binary search of A comma mid plus 1 comma L comma X. And in the tree data structure we go to right subtree. With the parameters A mid plus 1, 3, L is also 3 and X is 20. Okay, we call a recursive algorithm, same recursive algorithm, same function with the parameters A, 3, 3 and 20. Now we are in the beginning of a recursive function with the parameters A, I, L, X, that is A, 3, 3, 20. First we check if L is equal to I. Here condition true. L is equal to I. 3 is equal to 3. There is only one element. That element is 20. Condition true. Then we check if X equal to A of I. 20 is equal to A of 3. 20 is equal to 20. Condition true. So return I. Return position of element 20 in the array. So return position, return index, that is 3. Return 3. So search is successful and return position of element 20 in the array. Position of element 20 is 3. So return 20 and binary search is completed.